So this class we are going to state about relation, what is included in your class 12 examination. Not only for board, it is there in JEE syllabus also. In class 11, you must have done relation defined from set A to set B, isn't it? There it was relation defined from set A to set B. Here, the relation going to be from set A to itself. Okay? So, relation from set A to itself. You know, a relation, if we denote this by R, if it is from A to B, then R is a subset of A cross, isn't it? So, if we plan to define a relation from set A to itself, then R will be subset of A cross. Okay? A relation defined on set A is subset of A cross. So, if I take A equal to, say I am taking L, M, N, three members of the set, then A cross A will be what? LL, LM, LN, ML, MM, MN, and then NL, NL, NM, and NN. Okay? This is relation defined from set A to itself. If we consider this relation R1, LL, MM, NN, and R2 equal to, say I am writing LL, MM, NN, and taking ln also over there. There may be more elements. If somebody writes another element n comma m, do you find any difference between these two? And can you define mathematically these two relations? What is the difference between them? In this set, all first and second elements are repeated, isn't it? Here, not all repeated, some extra elements are there. These kind of relations in mathematics will be termed as identity relation. Okay? And this kind of terms, this kind of relation will be defining as a reflexive relation. I haven't told you what we are exactly going to do today. In your class 12 syllabus, the syllabus is on types of relation. Obviously, these are two types of relations. Identity relation one type, reflexive relation another type. Now, if you consider this whole set, say I am taking R equal to A cross A, then this set has a name. I am not writing all the elements again. This has a name which is known as universal relation. Okay? This set is known as universal relation. Why? Because you can see that number of elements here in A cross A is 3 into 3, that is 9. All those 9 elements taken here. That's why it is universal relation. I'll give you the mathematical definition. But before that, let me define other types of relation. If we have defined a relation like this, R equal to 5, then this is called empty relation. Okay? What can be the example for these two? I am taking from numbers. Let A equal to 2, 3, 4. Okay? These are 3 elements. 2, 3 and 4. Now, if we write A cross A, then you know what will be there? 2, 2. All 9 elements like before will be there. Finally, tail 4, 4. I am taking a relation this manner. R1 equal to 2, 3, 2, 4. It's a relation on E. We define this way. And this one going to be, as per definition given over there, this relation is universal relation. Isn't it? I am defining another one here. That R2 equal to, I am writing in the form of ordered pair, A comma B, such that mod A minus B greater than or equal to 0, AB belongs to A. Okay? Then what will you get over there? Mod A minus B, I am not saying greater than or equal to 0, strictly greater than 0. Then don't you see that R2 will be containing all these, actually equal to 0 also possible, because 2 minus 2 also there, 3 minus 3 there, 4 minus 4 there. This relation is actually A cross C. So this is an universal relation. This is an universal relation defined on E. Am I correct? This is an universal relation defined on E. Why? Because if you take any two elements from this set, their difference and modulus will be either greater than 0 or equal to 0. No other possibility. So this includes all these elements. This is universal relation. This we can say universal relation. But on this set, if we define another relation, say I am writing R3 on A defined as follows. What is that? R3 equal to AB such that mod A minus B greater than or equal to 15. Is it possible here to because the set A is what? 2, 3 and 4. So R3 will never give you any element from A cross. So this relation going to be empty relation. Okay? This is called empty relation. Let me define these three relations first. That is identity, universal and empty relation. So what we have done in class 11, it includes these two, isn't it? Taking this, that this is relation on E. Then what we have done in class 11, that is, I am writing those first. One is identity relation, the other one is universal relation, and the third one is empty relation. Then I have explained with the example. What is an identity relation? Let me write the formal definition. Here I have explained what is that. Elements will be of this form only. Only LL, MM, NN. This structure. Okay? But LN and NM should not be there. So let me give you the formal definition. A relation R on A, are defined on A, is said to be identity relation if for A belongs to A for all, you write for all. Symbol for all you write for all A comma A belongs to R. Okay? So by definition R will be what? R equal to A comma A for all A belongs to A. Only these kind of elements will be there. This is called identity relation. This we have defined as this one, identity relation. Only A comma A will be there for all A belongs to A. Then what is universal relation? This we have defined identity relation. What is universal relation? A relation defined on R is universal if every element are on A, you say, is a set. If every element of A is related to itself. Okay? And we write universal relation by this letter U or A cross. All the elements of the Cartesian product will be there. With the example, I have explained what is universal relation. And then what is empty relation? Formal definition. A relation R defined on A is empty if no element of A is related to any element of A. This also I have explained with the example. What is that example? Go through this example. That why I have defined mod A minus B greater than or equal to 15. That is not possible. Then this is empty relation. Relation R defined on A is empty if no element of A related to any element of A. Then this is empty. Alright, you have understood? But in today's class discussion, we will mainly learn what is included in your syllabus. This you must know. But in types of relation, you are going to learn mainly these three types of relation. Types of relation, we are going to learn these three types: reflexive relation, symmetric relation, and transitive relation. Okay? There is reflexive, there is symmetric, and there is transitive. So let me define one by one. What are reflexive, what are symmetric, what are transitive. I think basic concept you have got in these three types of relations. But mainly I told you, I am going to discuss this. We are taking the set A only. A, maybe any set, not a void set. Then relation on R relation on A is reflexive if under what condition reflexive? If for all A belongs to A comma A belongs to R. Defined on A is reflexive if for all A belongs to A comma A belongs to R. Then this is okay. Now I have to say something. Identity relation, you have seen that their elements will be of this form. What form? That LL, MM, NN. Only this type. No other element will be there. But reflexive may include this kind of elements also. LN, NM, where the first element is not equal to the second element. So relation R on A is reflexive if for all A belongs to A comma A belongs to R. Let me explain with one example. I have taken the set A equal to, say I have taken PQR. Then already I have explained, but still I am writing. Then PP, QQ, RR is a reflexive relation, but it is the smallest one because we can take element like this also in the relation. Okay, but in identity relation, we cannot include P comma R. You understand what I said? Hope you have understood. So this one is a reflexive relation. Symmetric relation, how you define? There may be more elements. RP may be there, PQ may be there. Symmetric under what condition? A relation R on A is said to be symmetric if for all AB belongs to AB belongs to R implies B comma A belongs to R. Okay? Under this condition, it will be symmetric relation. So, let us define one symmetric relation on the set. Okay? So, this relation is said to be symmetric if for all A belongs to A, for all AB belongs to A, AB belongs to R implies BA belongs to R. Let me clarify this part on the same set. Which set? A equal to PQ. So I am defining R2 equal to PQ PR. This is not symmetric because PQ is there but QP is not there. So not a R3 equal to, say I am writing only P comma P. Is it symmetric? See the condition. Condition is that if PQ is there, then QP has to be there. This is the condition. If A is there, BA should be there. If PQ there, then QP has to be there. But if it is not there, we will not think about the opposite PQ. If PQ there, then only QP. If PQ is not there, still it is symmetric relation. This is a symmetric relation. R3. Now think about this. R4 on the set A equal to PQR only. I have written before. R4 we are writing PQ, QP, RR. This is also a symmetric relation. Addition of this element doesn't matter because PQ and QP are there as the element, so it will be symmetric relation. I am taking another one. R5 equal to just PQ. Is it symmetric? Not a symmetric. If you have included PQ, then QP must be taken over. This kind of relations, symmetric relations. Now, let me define another relation that is called transitive relation. We will be defining that now. Transitive relation. A relation R on A is transitive if for AB and BC belongs to R implies A comma C belongs to R. Again, the same concept. If A, B, BC not there, we won't think about is. Okay? We think about AC if and only if AB and BC both are included. Like from the same set I am taking that PQR. From that set only I am taking element. Check R6 equal to PR transitive or not. Is this transitive? Yes. If ABBC there, then AC has to be there. If only maybe there, no problem. BC is not there, we don't think about this. So this one is a transitive relation. Taking say R7 equal to PR RQ. Is it transitive? Not a transitive relation. This one not transitive as but PQ does not belong to R. So this is not transitive. As PR and RQ there, but PQ is not there. So it won't be transitive. RH equal to, say I am taking PP, QQ, RR. Is this transitive? Is this transitive? Yes. This is a why transitive relation? Because we think about transitivity if ABBC there, then only we think about AC. Okay, otherwise no. So now I take some practical example. Okay. So in class 12, as I told you earlier, we'll be discussing mainly these three types of relation. That number one, reflexive. Number two, symmetric. And number three, transitive. And definition you have understood, isn't it? For reflexivity, I am just writing in brief. A is a set, on it you have defined for all. A comma I just remind you, for all you use this symbol. For all A belongs to A comma A belongs to R. Symmetricity, for all you use this symbol. For all AB belongs to A comma B belongs to R, implies B comma A belongs to R. Then this is symmetric, reflexive, and transitive under what condition? Transitive for A, B, C belongs to A, B, BC belongs to R implies A comma C belongs to R. Okay? Clear? Now, suppose somebody is very interested to take example from the practical world or from daily life or from mathematics only, but problem is stated with different manner. Like this, you are defining relation on the set of set of straight lines, perpendicular straight lines in a plane. Do all the straight lines are elements of the set? You agree or not? Now, you have to state that relation is perpendicular to, just writing the sum, a relation R on the set of straight lines is defined as follows. What is that? Okay? How you define? Relation R on the set of straight lines is defined as follows. That are going to be L1, L2. See the way I am taking? Condition product if the line 1, line 2, line 3, line n is there. You are taking their condition product. That L1 perpendicular to L2. Okay? Check whether the relation is reflexive, symmetric or tangent. Take reflexivity, symmetricity and transitivity for this. All right. Check this relation reflexive, symmetric or transitive. How you check? So you need to start this manner. Reflexivity first you check. What is the condition? A comma A has to be there. But can a line be perpendicular to itself? No. R is, you are sure, you start this manner. R is not reflexive. Why it is not reflexive? That you have to state. Why not reflexive? Because as a line can't be perpendicular to itself. Am I correct? But R is symmetric. Why R is symmetric? R is not reflexive, but R is symmetric. Why? R is symmetric because if L1 perpendicular to L2, then L2 perpendicular to L1. Agree or not? Okay, so your comment will be like this. R is symmetric as L1 perpendicular to L2 implies L2. This is true for any two perpendicular lines. L2 perpendicular to L1. So the relation. So if AB there, L1, L2 there, L2, L1. R is transitive or not? R is not transitive. because I'm just drawing a diagram for you for your better understanding. Say this is L1, this is L2. You have to take L1, L2 and L2, L3. Now L3 is this. It also has to be perpendicular. So what is your observation? L1, L3 perpendicular or parallel? They are becoming parallel. So you write for 3 lines, this way you will answer. For 3 lines, L1, L2 and L3. For 3 lines, L1, L2 and L3, L1, L2 and L2, L3 belongs to R, does not imply, does not cancel it. Okay? But one thing I'd like to say, this is true for 2D. In 3D it might happen. That might be, these are actually lines in a plane I told you in the beginning. Show the relation, not tangent. This one is symmetric. True. Reflexive, not reflexive. So it is not for reflexivity and symmetricity, but reflexivity and transitivity, but symmetricity is obeyed. Let us take another example. What is that? From practice only, just take an example like, just a minute. Just a minute. Somehow not working. Okay. You write the relation first. A relation R on, no, a relation defined on set of people in a locality this manner. What manner? That R equal to A comma B, where A is brother of B. Is this reflexive, symmetric or transitive? You decide, then I will. R equal to what I have written? R equal to AB. Whatever you write, A is brother of B. Is this reflexive, symmetric or transitive? Think and then answer. Answer. Is this a reflexive relation? No. A person cannot be brother of himself. This is not reflexive. You will give the reason. Number 2, is it transitive? AB belongs to R. does not imply BA belongs to R. Agree or not? Agree or not? Why? Because if B is a girl, then A is brother of B, but B is not brother of B. Okay? Is brother of, you are defining that on set of people in a locality. Then number 3, this one true I guess. AB, BC belongs to R will imply that A comma C belongs to R. Okay? A brother of B, B brother of C. So A must be brother of C. Okay? Is this okay? This is reflexivity, symmetricity, transitivity. We have it. Now take another example. And not from practice. This is an exact problem. A relation R defined on the set of real numbers as follows. R equal to AB, A minus B is divisible by C. Decide whether it is reflexive, symmetric and transitive or not. Don't take example. You have to give the general proof. You cannot take example here. Not possible. Okay? I'm just showing you how to answer this. Because example you cannot take. If you take example, you are wrong. No marks will be given for that. Okay? You want not, we don't know. You start always this manner. R is reflexive. Why? As A minus A equal to 0 divisible by 3. That is for this ABR. What? You take AB, we have defined on real number. Okay, but divisible by 3 for all real number not true. So I am writing this one for integers. R is defined on R is defined on the set of integers. AB are integers. A minus B divisible by 3 and AB belongs to set. That means set of integers. Or you write I, no problem. That is for A belong. Now A minus A 0 means divisible by 3. 0 divisible by 3. Therefore for A belongs to I, A comma A belongs to R. So R is reflexive. R is symmetric. How do you prove this? That is for AB belongs to R. What does this imply? A minus B is divisible by 3. Now, is also divisible. You agree or not? If A minus B is divisible by 3, B minus A has to be divisible by 3. So, R is symmetric. Take R symmetric. Okay? So, R is symmetric. Here, is R transitive? Let us check. Let A minus B, M be an integer. Let A minus B equal to 3M, where Mn belongs to I. Then A minus B, A minus C equal to A minus B plus B minus C. 3 into M plus N. This is by 3. Therefore, we can write this way also. ARB, BRC. Meaning A related to B and B related to C implies ARC. So, right? So, the relation is transitive. Therefore, R is transitive. Okay? Now, in a problem, if you find all three are going to be valid, all three relations are going to be valid, then that relation is said to be equivalence relation. So let me define. A relation R on A, on the set A, is an equivalence relation if it is number 1 reflexive, symmetric, and transitive. If all three relations are valid over there, then it is said on the set A, then it is said to be all three are valid. Then it is equivalence. So let me check with this example, setting one example for you here. A relation R on the set of real numbers is defined as follows. What is that? That is R equal to A comma B such that mod A minus B is divisible by 4. Check whether it is an equivalent solution or not. You have to check this. mod a minus b divisible by 4. Is it an equivalence relation? We'll answer this way that a minus a equal to 0 is divisible by 4. So, R is reflexive. Number 2, let, always you are assuming that A, B, C belongs to what? R, R. You take the R this manner always. This thick R will imply that it is set of real number. Relation only by R, but thick R means set of real number. Let mod A minus B equal to 4M. 4M. Mod B minus C 4M. Required to prove mod A minus C is divisible by 4. Not vector, just mod A minus C. That is required to prove mod A minus C, but to prove mod A minus C is equal to 4 times L. L is an integer. Okay? Mod A minus C 4L where L is an integer. But how will you prove this? You have taken A minus C divisible by 4, then A minus C 4L. How will you start? Mod A minus B, I am just telling you briefly. Mod A minus B 4L. What does it imply? And what does this one imply? Isn't it? Therefore, so A minus C divisible by 4. Answer. Clear? Understood? I hope you all have understood. Next session I will be discussing with equivalence clause. Okay?